The requirement for a ground rod for a subpanel in a detached garage, while not explicitly stated in a single article, is implied in several National Electrical Code or NEC sections. Article 250.52a states that where an alternating current or AC system is grounded to a rod, pipe, or plate electrode, the grounding electrode conductor must be connected to the grounding electrode at a single point. Article 250.58 says that made electrodes shall be installed according to the requirements of Article 250, Section 5. Article 250.56 dictates that made electrodes should be driven, installed, and connected following Section 8 of this article. The concept of parallel grounding arises when a ground rod is added to a system already grounded through direct burial cable. Introducing another ground path isn't generally recommended because it could create excessive voltage drop and safety risks. Regarding the direct burial cable, the NEC section 300.5d specifies that it must be buried at least 24 inches below the surface. The recommended approach, based on the NEC, consists of a few steps. Firstly, connect the subpanel to the grounding electrode system using the direct burial cable. Secondly, make sure the direct burial cable is buried at a minimum depth of 24 inches. And thirdly, avoid driving a ground rod to supplement the direct burial cable. Adhering to these steps helps to meet code standards and mitigate the dangers of creating a parallel ground path. The inspector's decision might have stemmed from a misunderstanding of code requirements. Consider reaching out to the inspector to discuss and clarify the specific code articles related to the installation. It's essential to understand the nuances of grounding and bonding within the electrical system to ensure safety and code compliance. The grounding system serves as a critical safety measure, providing a low impedance path for fault current to return to the source. This path facilitates the operation of overcurrent protection devices, such as circuit breakers or fuses, which then disconnect the circuit, minimizing the risk of electrical shock or fire. The grounding electrode system typically consists of various elements, including ground rods, ground plates, metal underground water pipes, and the building's metal frame. The NEC outlines specific requirements for the size and installation of these electrodes depending on the system voltage, available fault current, and soil conditions. The grounding electrode conductor connects the equipment grounding conductors and the grounded conductor, if present, to the grounding electrode system. This conductor must be sized appropriately based on the size of the service entrance conductors, as specified in NEC Table 250.66. Bonding refers to the connection of all non-current carrying metal parts of an electrical system to create a low impedance path for fault current. This includes metal enclosures, raceways, equipment frames, and other conductive components. Bonding ensures that all metal parts are at the same potential, minimizing the risk of electrical shock if a fault occurs. Equipment grounding conductors, or EGs, provide a path for fault current to return to the source from metal enclosures and equipment frames. These conductors must be sized according to NEC Table 250.122, based on the rating of the overcurrent protection device in the circuit. In the case of a subpanel installation in a detached garage, the grounding and bonding requirements are particularly important. Because the subpanel is located in a separate structure, it's essential to establish a proper grounding electrode system to ensure safety. The NEC generally requires a grounding electrode system at each building or structure served. However, there are exceptions to this rule, such as when the structure is supplied by a single branch circuit and does not contain any multi-wire branch circuits. In most cases, a detached garage with a subpanel will require its own grounding electrode system, typically consisting of one or more ground rods. The size and number of ground rods required will depend on the soil conditions and the available fault current. It's important to drive the ground rods deep enough into the earth to ensure good contact with the soil. The NEC specifies that ground rods must be driven at least 8 feet into the ground, and they must be spaced at least 6 feet apart. The grounding electrode conductor that connects the subpanel to the ground rods must be sized according to NEC Table 250.66, based on the size of the service entrance conductors feeding the subpanel. In addition to the grounding electrode system, it's also important to properly bond all metal parts of the subpanel and the equipment it serves. This includes bonding the metal enclosure of the subpanel to the equipment grounding conductor and bonding any metal raceways or enclosures that contain circuit conductors. The equipment grounding conductors must be sized according to NEC Table 250.122, based on the rating of the overcurrent protection device in the circuit. When using direct burial cable to supply power to a detached garage, it's important to ensure that the cable is listed for direct burial use and that it's buried at the correct depth. As you mentioned, NEC Section 300.5D requires direct burial cables to be buried at least 24 inches below grade. This depth helps to protect the cable from physical damage and ensures that it remains in good condition over time. It's also important to install the direct burial cable in a trench that is free of rocks, debris, and other sharp objects that could damage the cable. The trench should be backfilled with clean soil that is free of large rocks or other materials that could puncture the cable. When connecting the direct burial cable to the subpanel, it's important to use connectors that are listed for direct burial use and that are properly installed. The connectors should be sealed to prevent moisture from entering the cable and causing corrosion. In some cases, it may be necessary to install a ground fault circuit interrupter or GFCI circuit breaker in the subpanel to provide additional protection against electrical shock. GFCIs are required in certain locations, such as in bathrooms, kitchens, and outdoor areas where there is a higher risk of exposure to moisture. It's also important to properly label the subpanel to indicate its purpose and the circuits it serves. The labeling should be clear and easy to read, and it should include the voltage, amperage, and other relevant information about the subpanel and its circuits. Finally, it's always a good idea to consult with a qualified electrician or electrical inspector to ensure that the subpanel installation meets all applicable codes and standards. A professional electrician can help you to properly size the grounding and bonding conductors, select the appropriate grounding electrodes, and install the subpanel in a safe and compliant manner. In summary, the installation of a subpanel in a detached garage requires careful attention to grounding, bonding, and direct burial cable requirements. By following the NEC guidelines and consulting with a qualified electrician, you can ensure that the installation is safe, compliant, and provides reliable power to the garage. Understanding the nuances of electrical codes is crucial for ensuring safety and compliance in any electrical installation. It is recommended to always consult the latest edition of the NEC and seek guidance from qualified professionals for specific applications.